Okay, so today we're going to be looking at sine and cosine values, a bit of a review from last class, looking at the key ideas we're working with. So, take a minute or two to pause the video, copy down the table, fill in the values for the exact value table. Okay, welcome back. Should have filled in your values nicely. Let's have a look at what these are going to be. So it's really important on this course that you can generate this table of values to have on your paper when working with unit 3 questions. So these are the values for the exact value table. We start with 0, a half, root 2 over 2, root 3 over 2, 1. And then we write it backwards. Then we divide each row by itself. We divide the sine value by the cosine value, ignoring the denominators because they're always the same. We get the exact value table. Very important that we can pull this up quickly and then use these values. With time, we'll start to just memorize them during this unit. We are going to use this a lot for the next 2 months while we look at this unit. A little bit of a reminder about what to know for this topic. So looking at the coordinates of a point on a circle centered at the origin. So if we have any angle drawn in standard position, remember that standard position means that we're rotated from here in an anti-clockwise direction, like this one, we define an angle. So any angle written in standard position in a circle with radius r centered at the origin, there is a point P where the terminal ray intersects the circle. And what we see is that we know that the cosine of theta is going to be x divided by r, and the sine of theta is going to be r. In the unit circle, when r is equal to 1, that simplifies to the cosine of theta is equal to x, and the sine of theta is equal to y. But if the radius isn't 1, then we have to divide through by r. For each of these equations, we can multiply both sides by r, giving us the coordinates here, which means the coordinates of the point P is r cos theta sine cos theta. In the unit circle, when r is, so if r is equal to 1, in the unit circle, it gives us cos theta, sine theta. Sine theta is the y value, cos theta is the x value. Key fact to know on this one. Let's have a go at using that. All right, let's warm you up. I think we'll do what we do for this one. Discuss with the people next to you, try and figure your way through the problem. Take a minute or two for this question. Pause at home. Right, so remember that an equilateral triangle like this one is going to have an angle of 60 degrees. The equivalent radians for that is pi over 3. If we cut that in half, then this angle there is going to be pi over 6, which means that this angle here is going to be pi over 3. It means this angle here is going to be pi over 3, and this angle here is pi over 3. So we want the angle for Q. So the angle for Q is theta is equal to 2 pi over 3. This is our angle for Q. So that then leads us down to 2 possible outcomes. We can cross off A, we can cross off B. Leaves us with 2 possible outcomes. Then we have to think about the quadrant that it's in. We have to think about the quadrant that it's in. The quadrant that it's in means that the cosine value is negative. But That is why this one is a good distractor, because it's the angle. It's the angle that's going to generate the negative. When you put in 2 pi over 3 into the cosine value, that will come out negative. And then this negative will turn it into positive, meaning that this here is a strong distractor. You're supposed to sort of understand that it should be negative over here, and that negative is misleading you because the cosine function, when you put in this obtuse angle, will produce a negative value. So this one is wrong, and it leaves us with the correct answer here. Okay, let's move on. No questions? Let's have a look at this. Why don't you guys take a couple of minutes to discuss this on your tables, and then I will run through it for you. Pause at home. All right. So when I present a question like this one, and I ask you to pause the video, you have to pause. Don't just go straight on to me showing you the solution. In the classroom, and you don't know what to do, don't just wait for me to show you, because you know I'm going to show you. That is really, really bad approach. One of the hardest parts of math at this level is problem solving. You have to learn to solve a problem in an exam that you've not seen before, using the tools and concepts that we've developed. So when we put up a question like this one, you have to struggle at it. You will not get good at math if you don't practice struggling to solve unknown problems. When you're working with homework sheets, when you get this situation, it's like, I have no idea what to do here, I'll give up, I'll look at the answer at the back. That's why you won't develop in math. So in math, you have to struggle. So try, draw a diagram, try, draw a graph, try, put down some formulas that might work and see where it leads you, and then backtrack when it doesn't, try again. That is problem solving. If you don't develop that skill in those situations where you're like, I have no idea what to do, if you don't develop that skill, you will not develop to a good mathematician and get a 5 on this course. It's really important. So there's a few ways we can solve this. I went around the room and I saw 3 completely different solutions. The solution I'm looking for comes from basically what we're looking at today, using today's information. But there is also a solution using the circles equation. So the circles equation is given here at the beginning, that any circle defined in at the origin, it can be defined by this, and you can put in the values and then solve and you get the answer that way. Or, as MJ did, you can just find a right angle triangle there. You've got a right angle triangle being defined here. So there's a right angle triangle being defined there, and one of the sides that you don't know is R, that you're after, and you're told the other 2 sides. This one is this, and the length of that, because it's no longer in the coordinate system, it's not positive or negative, it's just positive length. You've got a right angle triangle. Pythagoras' theorem is going to give you the answer. There were 3 good, strong solutions you can use for this. The solution we're going to look at today is using the ideas of the unit circle, or the circle drawn in the coordinate system. Let's have a look at that one. So there's 2 ways to find the angle. So in order to pull up this solution, you need to find the angle. You need to find this angle here. You need to find this angle here. There's a couple of ways forward. So finding that angle there can come from an understanding. Basically, we have the same sine and cosine value. If you understand the exact value table, you should start to become familiar with that they are the same when we're at pi over 4. They're the same when we're at pi over 4. You can also do understanding from the symmetry. This has been cut perfectly in half, and that means that you have to cut 90 degrees in half, or pi over 2 in half, which is pi over 4. So we should be able to see that this angle here, sorry, let me go for this angle here. This angle here is minus pi over 4. This angle here is minus pi over 4. So a full rotation is 8 pi over 4. A full rotation is 8 pi over 4. This is 1 less, 7 pi over 4. This is 7 pi over 4. A full rotation is 8 pi over 4. Half a rotation is 4 pi over 4. And then work your way through. Or you can just cut it into lots of quarters and go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. And you'll get it. So we find that the angle we're after is theta is equal to pi over 4. Let me show you another technique you could use. So another formula, which is a useful formula for us, comes from y equals minus x. So what this can actually do, so what's the gradient of that? What's the gradient of that straight line?
Minus 1.
Minus 1. So the gradient is minus 1, but that actually is y equals tan theta x. So the straight line drawn through the origin will have the gradient m is equal to tan theta. This will help you with problem solving, this formula. So m is equal to tan theta when the straight line in the coordinate system is drawn passing through the origin. It's a useful formula. So, in this case, when tan theta is equal to minus 1, it tells us that theta is equal to 3 pi over 4 plus n pi, which implies theta is equal to 7 pi over 4. So there's a few different ways, there's two different ways. There's sort of one that I've drawn in red and the one that I've drawn in blue that leads us to theta being 7 pi over 4. Both of these methods we can use to kind of go our answer. So if we know the coordinates of this point, so what we should use is the coordinates in this system is r cos theta, comma r sine theta. We know that the angle is 7 pi over 4. The cosine of the angle is 7 pi over 4. Now that should be equivalent to using the symmetry. If we reflect that up to here, this is pi over 4. If we reflect that, I'm using the cosine value because they're both positive. We can see from the symmetry here that the cosine of 7 pi over 4 must have the same value as the cosine of pi over 4 from the symmetry. We go straight up, we're reflecting it up, they're both positive, both coming the same way. And then we pull that from the exact value table. So if the cosine value is pi over 4, then that's root 2 over 2. Root 2 over 2. So combining these two together, we know that r cos theta, so we know that r cosine theta is going to equal this value here, 6 pi over root 2. So this means that r times root 2 over 2 is equal to 6 over root 2. Which tells us that r is equal to 12. Okay, individually now, copy down the diagram and fill in and complete the values. Individually now, you do. Take 3 minutes for this one. Okay, so for these values, these values are quite easy, we need to pull up fairly quickly. In radians, this point here is the angle is 0. Here is pi over 2. Here is pi. Here is 3 pi over 2. And then here is 2 pi. So if we want the cosine value, is the cosine value the x coordinate or the y coordinate? Cosine value is the x coordinate. The x coordinate here is 1. Cosine value is the x coordinate. X coordinate here is 0. Here it's -1. And here it's 0 again. Sine value, is it the y value or the x value?
The y value.
The y value. So here it's 0. Up there it's 1. Here it's 0 again. And here it's -1. These values you can pull up very quickly from just thinking about the unit circle. Alright, I'm going to do this one. So what we're looking at here is we wish to find the coordinates of point P. So we can see here in the diagram that this value is going to be a half. We wish to find, if we wish to find the x coordinate, we can use the circles equation in the, so the circles equation, we remember back from the beginning. This is the circles equation for a circle centered at the origin with radius 1. And we can use that one, where are we, we're here? No, not but here. You remember that the coordinates there are cosine of theta, sine of theta. The coordinates in the unit circle is this. The coordinates in it, any coordinate is this. Putting that into the circles equation. So the circles equation is x squared plus y squared equals 1. This implies that the cosine squared of theta plus the sine squared of theta is equal to 1. This formula is hugely important. And it even has its own name. So this is the Pythagorean identity. This is the Pythagorean identity. I'll just give you a minute to write that one down, give it its name. Make a careful note of this one. You're going to have to memorize this formula. We're going to use this one a fair bit. Very useful. So from the diagram, we know that the sine value is equal to a half. So we can put this one into the Pythagorean identity, and it will lead us to an answer for the cosine value. So the cosine squared of theta plus a half squared equals 1. This implies that cosine squared of theta plus 1 over 4 is equal to 4 over 4. So when I open up the squared value, the sine value or the cosine value, and I see what the denominator is, at that point I see here that the denominator is 4, I change 1 to have the same denominator. 1 is easy to change denominator, you just turn it, if the denominator is going to be 7, then it would be 7 over 7. So that means that when I subtract 1 over 4 from both sides, I come fairly quickly to the cosine squared of theta is equal to 3 over 4. This implies that cosine theta is equal to, now when you square root both sides of an equation, you have to consider both plus and minus solutions. Like with quadratic equations, where you square root both sides, you have to consider both a positive and negative solution to the equation. Just simplifying that will give us root 3 over 2. Now lastly, we must consider which quadrant we're in. We must consider which quadrant we're in. Which quadrant are we in? We're in the first quadrant. In the first quadrant, sine and cosine are positive. So this is quadrant 1. So this implies that the cosine theta is equal to root 3 over 2. It won't be negative because we're in the first quadrant. So the coordinates of P are root 3 over 2, 1 over 2. You can take a read through this explanation here a little bit if you want in your own time. I'm not going to run through this, basically another working of the same question. I'd like you to have a go with this question now. This is our last problem solving question. Work together in pairs on this one. Take 2 or 3 minutes. Problem. Okay, so what are we going to do? We've got a problem, haven't seen. How do we solve it? So we start off with, we got an xy plane, terminal ray of the angle in standard position intersects the circle with radius 10 at point x, comma 6. What is the value of x? So let's try and sketch it a little bit. So we've got a circle like this one. And we can see that the y value is positive. So we've got a point here or here where we have x, comma 6. X, comma 6. We don't know which one of these two it is yet, as I'm unpacking the question. The coordinate here is 10, comma 0. So all I've done at the moment is I've looked at the question and I've written down the information presented and I've turned it into a diagram. This is your best problem solving strategy. Once you start to visualize it like this, it becomes a little bit easier. So the coordinates of the point, according to our formula, according to the information presented earlier in our do now, the coordinates are r cos theta, r sine theta. So if we come back to this, the coordinates here are r cos theta, r sine theta. So let's pull off the 6. Pulling off the 6 from that, it tells us that r, well we know that r equals 10. So 10 sine theta is equal to 6. So from the diagram here, r sine theta is the y-coordinate. We know the radius is 10. So r sine theta is 6. So 10 sine theta is 6. This implies that sine theta is 6 over 10, which is 3 over 5. So now we pull up the Pythagorean identity. So Pythagorean identity is cos squared theta plus 3 over 5 squared equals 1. Opening up our bracket, we get the cosine squared theta plus 9 over 25. The denominator is 25, so we change this to be 25 over 25. Subtract the 9 from 25, gives us cos squared theta is equal to 16. 25 minus 9 is 16 over 25. So the cosine of theta is equal to plus minus We're going to square root of those two. That's going to give us 4 over 5. We are finding the value of x. So we have to come back to this here. X is equal to r cos theta. So x is going to equal plus and minus 4 over 5 times the radius. Let me just draw up that bit there. So let me show it again. X is equal to r cos theta. So x is equal to 10 times plus minus 4 over 5. Plus minus 8. So anything, then, I'm just going to check at the end before I finish. So anything here in the question, I'm going to reread the question. Anything here in the question that implies what quadrant it's in. Just double check the question when you come to the end of one of these and say, was there something that said it was in quadrant 2 or not? If there isn't, there's nothing here in the question which says which quadrant it's in. So the answer is going to be plus minus 8. So when it's over here, it's going to be negative 8. When it's in the first quadrant, it's going to be positive 8. Those are our two possible solutions. Right. Basil, put your phone away.
It's pretty easy. I just passed that.
Well, that's because the pipe.
It only gives a.
It only gives one.
Usually.
But you can imply the other
Yeah.
one.
Oh, yeah, that one.
That's because the reason it's called the Pythagorean identity is it's based on Pythagoras' theorem.
Yeah.
So the two are always going to be able to solve the same problems technically. All right. Take the last exit ticket question for this one. We've got 2 minutes. Pause at home. Okay, looking at our answers. So firstly, we've got an angle of 5 pi over 6. So we consider the unit circle like this, and we could consider where 5 pi over 6 is going to be. This is 5 pi over 6. We can reflect it back to the first quadrant, and this would be pi over 6. So this is going to be pi over 6.
Nice one.
So here, with our point, when we have 5 pi over 6, Houston, when we have 5 pi over 6, we're in the second quadrant. So instantly, we know that the x-coordinate has to be negative. These ones are gone. We know that the x-coordinate has to be negative. We go back to our exact value table. And from the exact value table, pi over 6, these two coordinates, root 3 over 2, 1 over 2. So the coordinates here are root 3 over 2, 1 over 2. That means the coordinates at this side is minus root 3 over 2, 1 over 2. Now in the question we are told that we have a circle with radius 4. So this coordinate here is 4, comma 0. So these coordinates need to be 4 times minus root 3 over 2, comma 4 times 1 over 2. That's going to give us minus 2 root 3 and 2. Do any of them match that? Not this one. There's our correct, here is our correct answer.